right, we're going to talk about the fundamental theorem of algebra today. So the fundamental theorem of algebra says that if p of x is a polynomial of degree n is greater than 1, then p of x equals 0 has exactly n roots, including multiple and complex roots. What that's really saying is the degree is how many roots you have. They may be real roots. Those real roots might have multiple of the same roots, and you might have complex roots. Okay? So we're going to kind of take everything we've worked on the last couple of sections and kind of put it together. So we're going to use Descartes' rule of signs, we're going to use the rational root theorem, and kind of bring it all together. Okay? So the first thing here is, here's my polynomial. X to the fifth minus x to the fourth minus 3x cubed plus 3x squared minus 4x plus 4. Okay? And what I'm going to do is I'm going to be here and I'm going to just say the number of roots is 5, just so I can have that. So I'm going to start off by stating how many roots I have. Then I'm going to look at the positive roots. Okay? And all this does is I'm just laying the groundwork on trying to make myself a more efficient mathematician. Okay? So I'm going to look here, I'm going to count the different sign changes. So positive, negative, that's 1, negative, negative, no, negative, positive 2, positive, negative 3, positive, or negative, positive 4. So I have 4 sign changes. So remember, when I have 4, I could have 2 or I could have 0. Now I have negative roots. And so anywhere there's an odd power, I'm going to change the sign. Okay? So this is going to be negative now. So negative, negative, positive, 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 positive. And I see here that I only have 1 sign change. Okay? Now I'm going to go here and I'm going to just say imaginary. Really, maybe I should use the term complex. It's really complex. This is really just for me to understand that I want to make all those roots. So my positive, negative, and complex roots always, let's use that term. Let's use complex. Okay? So my positive, negative, and complex always have to add up to 5. So I'm going to have to go through every iteration. 4 plus 1 plus 0 equals 5. 2 plus 1 plus 2 equals 5. 0 plus 1 plus 4 equals 5. Your complex roots will always work out to be even numbers. So 0, 2, 4, 6, 8, 10, 12. It's going to work out to be something like that. Okay? Now I'm going to look at P. So if you remember, this is P. So now I have the factors of 4. Well, that's 1, 2, and 4. And then I look at the factors of my coefficient of x to the fifth. Well, that's only 1. So then I have P over Q, which is 1, 2, 4. So plus or minus 1, 2, 4. Okay? So that gives me a great starting point. All right? So first of all, I know there has to be a negative root. So I'm going to go ahead and instead of jumping in and starting plugging in my positive root, I'm actually going to start by plugging in my negative root. Now, that being said, this negative root may not be a rational number. It could be a radical number, right? So it could have the square root in it. But this gives me a good starting point. Okay, so I'm going to rewrite my coefficients here. 1, negative 1, negative 3, positive 3, negative 4, positive 4. Well, writing these up here, I actually know something right off the top of my head, right off. Notice how the signs are alternating here. That tells me something about what is my rational, my first rational 0. I did say we're going to start with the negatives, but once I got these up here, I did notice that these all cancel out. They all add up to 0. So that tells me that 1 is my rational 0. So let's go ahead and factor out 1. So 1 times 1 is 1. That gives me 0, 0, negative 3. This gives me negative 3, 0, 0, negative 4, 0. Okay? So now I'm in a position here. So I'm going to kind of write in orange what these powers are, okay? So this is x to the fourth plus 0x cubed minus 3x squared plus 0x minus 4. Well, notice here I have a power of 4, and then the next thing I have is a power squared, and then a constant. I can actually use factoring and principles of factoring to factor this, okay? So I want to go ahead and do that. So this is going to be x to the fourth minus 3x squared minus 4. So the factors of 4 that subtract to give me negative 3 are negative 4 and positive 1. Well, now I'm down to, I can factor this again into x plus 2, x minus 2, and then this one doesn't factor, right? So now I know that this is negative 2, this is positive 2. What does this work out to? Well, let's solve it. X squared plus 1 equals 0. Subtract my 1, subtract my 1. X squared equals negative 1. Square root. Square root. Remember when I get square root, I have plus or minus. So x equals plus or minus the square root of negative 1, which is I. So now I have I, negative I, and positive 1. There's my 5 roots of this polynomial. Okay? So you're kind of putting everything together. All right? We're gonna use Descartes' rule of signs to help limit some of my places. There's my one negative root, right? Negative 2. I would have gotten there eventually. The other thing is it helps me to know what rational numbers to plug in, okay? Because I want to work this down. I was able to find 1 because all these added up to 0, okay? So let's go to our next one. It says find all the zeros of f of x equals x to the fourth plus x cubed minus 7x squared minus 9x minus 18, okay? So the first thing I'm going to do is I'm just going to take a little bit of time and I'm going to write the number of roots is 4. The positive roots are, now I'm going to count the sign changes. Positive, positive, no. Positive, negative, 1. The rest are negative, so I have 1 positive root. Okay, now I'm going to look at negative roots. So that's going to change this. So anywhere I have, this is going to become, this is positive, negative, negative, positive, negative. Now I count the sign changes. 1, 2, 3. So I have 3 negative or 1. Complex, 1 plus 3 plus 0 equals 4. 1 plus 1 plus 2 equals 4. So I know I have some combination here. So I know I have 1 positive, at least 1 negative, and then I might have 0 or 2 complex. So then I'm going to look at P. So what are the factors of 18? Well, I know I have 1, 2, 3, 6, 9, and 18. I know that Q is 1, so P is equal to P over Q. Okay, so I'm not going to rewrite P over Q. That just takes up more time. So now I have some place to start. I know I have a positive root. I know I have a negative root. I can look here. I look at my coefficients. If I write them down, sometimes it's easier. 1, 1, negative 7, negative 9, negative 18. Okay? I know I probably have one positive, 1 negative. It doesn't mean that they're one of these. Okay? Make sure we understand that, because it could be a radical on there. Okay? So I know 1 isn't because these don't add up to 0. So it doesn't matter here because we have both. I'm going to go ahead and start with 2 just because most people tend to like working with positive numbers a little bit easier. So I'll just work with the positives. And a lot of times when I'm working on the board, I'll just kind of erase which one I've done. Okay? So if you're really want to just kind of get rid of that one, this one, that's fine. It works, doesn't matter. So 2 times 1 is 2. 3, 2 times 3 is 6. Minus 1, minus 2, negative 11, negative 22. That doesn't work. Okay? So positive 2 does not work. So 2 is gone. Okay? I could try 3. 3, this gives me 4. This gives me 12. This gives me 5. This gives me 15. This gives me 6. This gives me 18. And I found my positive one. Okay? So I found that positive 3 works. Do I need to test the others? No. I can immediately say, hey, it can't be positive 6, positive 9, or positive 18. It can only be positive 3 because it says that the possible rational positive zeros is 1. I only have one positive 0. I found it. So I don't have to do positive anymore. Now, I'm going to go in and start working with my negatives. So negative 1. So negative 1 times 1 is negative 1. This gives me 3. Negative 3, 2, negative 2. Didn't quite work. Okay? So negative 1 doesn't work. So let's try negative 2. This is where this is great with a whiteboard. I know a lot of you guys are doing it on paper, pencil. This gives me negative 2, 2, negative 4, 1, negative 2. Okay, that didn't work. So now I'm going to try negative 3. Okay, so I've already gotten rid of 1 and 2. So let's try negative 3. This gives me negative 3, 1, negative 3, 2, negative 6. There's my negative 1. Now, remember, this is x squared plus 1x plus 2. This is A, B, C. So once I get it down to 3 letters, I can immediately jump into the quadratic formula. This does not factor because there are no way to have the roots of 2, the factors of 2, add to get me 1. Okay? I only can subtract to get them. So if I come over here, I go negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 2 all over 2 times 1. So that gives me negative 1 plus or minus the square root of 1 minus 8 over 2, which now I have negative 1 plus or minus the square root of negative 7 over 2. So now I found my roots, right? This is going to become a complex number. So my roots are 3, negative 3, and negative 1 plus or minus I square roots of 7 over 2. There's my 4 roots. 1, 2, positive is 3, negative is 4. Got my 4 roots. Okay? 2 of them were real, 2 of them were complex. All right? We're going to do this one more time just for practice to get you guys going on it. And then that's kind of using the fundamental theorem of algebra. So number of roots, 4, positive roots, 1, 2, 3. So I have 3 or 1 negative roots. So this becomes positive, this becomes negative. I would have 1. Right? Positive, 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 no sign change, negative, 1. Complex is 0 or 2. So P, so the nice thing is because Q is 1, P is going to equal P over Q, right? So now I just have to find factors of 12. So that's plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Still a lot of them, but we now have kind of a way to start. So now I have 1, negative 4, 1, positive 12, negative 12. Okay? I could just start going through and eliminating pieces here. It doesn't really matter. I know right away that 1 doesn't work because these don't add up to 0, so I automatically know 1 doesn't work. I could plug in -1 because I know I have at least a negative root. It doesn't matter because I have 1 and a positive and a negative. So let's go ahead and plug in 2. Let's go ahead and start with 2. Just because most people like to work in positive. So this 2, -2, -4, -3, -6, +6, 12. Well, that's nice. 2 worked right away. Okay. Now, does that eliminate 2 as a root now? No, I actually can have multiple. So I already have my 1 positive though. So I could have 2 more positive though. But let's jump to our negatives now because I know I have 1 negative. It might not be a rational 0 though. It could be a radical 0. So we could stay on our positive, but let's jump to the negatives just because I know I have 1 of them. Hopefully I'll find it with these rational zeros and be done with it. So this gives me -1, this gives me -3, +3, 0. That's not going to work. So -1 does not work. So I'm now, my 1s don't work. We could try -2. So -2, this gives me -4, +8, 5, -10. That did not work. So -2 did not work. We could try -3 and see if it works. -3, that gives me -5, that gives me 15. This does not look like it's going to work. It looks like they're getting higher, so they're getting farther apart. We could keep testing them. -4, -6, 24, 21. That's going to get bigger. Even if I did -6, -8, 48, they're getting too big. Right? So they're continually going up. If I plug in 12, -12, I get -12, -14, -14 times -6. It's just too big. So I've actually done my negatives. Okay? So now let's go back to our positives. So it looks like our negative root is a radical root, not a rational root. So let's try 2 again. So that gives me 0. This gives me -3, -6. Oh, sorry. This is 0. -3 plus 0 is -3. -6, that's 0. Oh, look at that. 2 has a multiplicity. I should have saw that right away. Now I have x squared plus here. I can go ahead and put that in. So -0 plus or minus the square root of 0 squared minus 4 times 1 times -3 over 2, which is going to give me plus or minus the square root of 12 over 2, okay? Which that breaks up into the plus or minus the square root of 4 times the square root of 3 over 2. We know the square root of 4 is 2. So those 2's cancel out. So now I have 2 multiplicity of 2, and then plus or minus the square root of 3. So there's my 4 roots here, okay? So I have 2, comma, 2, comma, square root of 3, comma, negative square root of 3. Okay? So that's kind of bringing everything together that we've used. The rational root theorem, Descartes' rule of signs, and the fundamental theorem of algebra.